Welcome, travelers, to Adventures in Security. This is the fourth in a series of videos that explain and apply the U.S. Cybersecurity and Infrastructure Security Agency's Zero Trust Maturity Model, version 2.0. In this installment, we describe the model's network pillar. The study guide containing the information in the complete series is available via a link in the video description. CISA's Zero Trust Maturity Model 2.0 treats the network as a living space that must be reorganized so that every flow, whether it moves across an organization's Wi-Fi link or between cloud microservices, travels under the principle, never trust, always verify. The journey begins with a flat castle and moat design and culminates in a world where software writes security rules in real time, guided by live risk analytics. In the traditional state, the local network looks like an open warehouse. Internal computers all share the same large subnet, and a single perimeter firewall is trusted to keep outsiders out. Once an attacker slips past that wall, nothing stops them from strolling sideways toward more sensitive servers, as routes are static, most traffic is unencrypted, and intrusion sensors see only a blur of internal chatter. The initial stage starts with rearranging the floor plan. Administrators draw boundaries around particularly valuable workloads, such as an electronic health record cluster, the finance servers, and the 3D printers in the engineering lab, and allow only the protocols those systems truly need. East-west traffic is encrypted in TLS, so eavesdroppers cannot read credentials as they move across the building. These macro segments shrink the blast radius of a breach and give defenders clear choke points to monitor, a priority underscored by NIST's July 2024 Zero Trust Practice Guide, which demonstrates reference builds that encrypt every hop and refuse traffic not mapped to a known application flow. At the advanced rung, the organization trades heavy VLAN walls for lightweight micro-perimeters that surround each service and spin up or down on demand. Every new connection is checked against an identity-aware policy engine that examines the user's identity, the device they are using, and the perceived riskiness of their behavior. Certificates rotate automatically, sometimes every few minutes, so stolen keys expire before attackers can reuse them. Continuous telemetry is piped into anomaly detectors that build a behavior profile for every app. If an organization's web server suddenly attempts to communicate with payroll, the flow is blocked in real time. The optimal state turns the network into a programmable fabric. Software-defined networking tags each packet with metadata about the requesting identity, the health of the originating device, and the purpose of the session. An artificial intelligence engine monitors those tags and threat intelligence feeds. It rewrites routing rules on the fly, opening a 1-minute tunnel for a verified update job, throttling bandwidth when a device's trust score drops, or redirecting all traffic from a suspicious geography through a deeper inspection stack. Because configuration lives in infrastructure as code templates, a new standard, for example a switch to post-quantum encryption, can be deployed worldwide during the lunch period, a capability Microsoft and other cloud providers now expose through policy APIs mapped to CISA's optimal outcomes. Across every level, two practices keep the climb steady. First, data flow mapping documents exactly where information travels, ensuring that segmentation never disrupts legitimate work. Second, visibility pipelines merge firewall logs, endpoint telemetry, and cloud API events into a central analytics lake. The richer that data becomes, the faster the network can react to threats without human delay. That's it for this video. If you have questions or comments, post those in the video discussion. And until next time, be careful what you click.